Hello friends, today's anti-set is a review of ELR 13.3 with permutations and combinations and the counting principle. See if you can answer these three, come back and see if you have the right answers. Alright, so for number one here, that's definitely the counting principle about how many possible outfits are there. All we're doing is 8 times 4 to get 32 outfits. Okay, for number two, how many ways can Elena choose 4 songs from a list of 15 if the order of the songs is important? So order is important. Order is important for permutations. So we're going to take a permutation of 15, taking 4 at a time. You plug that into the calculator like I showed you, and you get the answer of 32,720. Okay, for number 3 here, we want to employ 8 cooks. How many ways can a manager choose 4 of the cooks to attend a training seminar? Here, the order does not matter, so it's a combination. So it's a combination of 8 things taken 4 at a time, and we put that in the calculator again, and we get it to be 70 different ways. All right, so today's objective is ELR 13.5. We're going to be analyzing data in a table, like we did for probability. This time we're going to be using a different formula, something called conditional probability. I'm going to learn about that in just a couple of minutes. Our homework, which is going to be due for Monday, is in this section 13.5, numbers 6 to 8. Whatever is easier for everyone, however you want to submit the homework to me. I've made a Google Doc for everyone. You could submit it on there, or you could email me the answers also. We are going to have a open no quiz, a Google form quiz on Monday. Monday's not going to be any kind of lesson. I want to go over and make sure it's all multiple choice. Make sure everyone understands what we've learned so far in probability. That's going to be on Monday. Okay, on the next couple of slides, I have the answers to the homework for 13.4. So if you do want to check your answers, you can. Please, again, if you have any questions, just let me know. Okay, here's this table about male and female students by grade level on the prom committee. So the question's asking, what's the probability that a member of the prom committee is a male who is a junior? So I'm going to look for the box. How many males are juniors? There are 3 of them. Out of the total of everybody is 12. So that probability is a 4th. All right, in this table, it's extracurricular activities. How many males and females are involved or not involved? Question's asking, what is the probability that a randomly chosen student is a female who is not involved in extracurricular activities? So females not involved in extracurricular activities are 120. Out of the total of everyone is 516. All right, so here we're getting into the meaning of what conditional probability is. Conditional probability says it's the probability that an event will occur given that an event already occurred. So there are different ways that they're going to present this to us. Either they're going to say the word given in the question, or they're going to write it like this, where it's got a capital P for probability of event B given event A. The formula, which is important to copy down for conditional probability, is this. To get the answer to these questions, we need to find the probability of these 2 events happening at the same time, A and B, all divided by the event that already occurred, which happens at the end, which is on the bottom, which is event A. Now, B and A are going to vary depending on what the question's about. Okay, here's this big table. We're going to have a couple of questions based on this table. These are age groups of a poll taken about who is for or against or has no opinion about a bill that would increase minimum wage. So here's our first question. What is the probability that a randomly selected person is over 60 years old, given, so here's that word given, that the person had no opinion on the state bill? So if I follow my conditional probability formula here, I'm going to figure out the probability of a person over 60, greater than 60, given, that's that slash, no opinion on the bill. Now, if I follow the formula that we got before, which is this one here, probability of B given A, I want to find the probability of those two things together with end, divided by the probability of what came after the given here, which is the A part. So in this question here, I want to first find the probability of a person greater than 60 and no opinion, divided by probability of how many people had no opinion about this bill. So let's take a look. Let's look at the columns here. All right, let's find the column where you're over 60 years old and they have no opinion about this bill. I notice it's right here. There are 40 of them. So that's my answer for the numerator of this problem. And then I want to find out the probability of, for the bottom part, how many of all the people had no opinion, and that's the total of this column of no opinion, which is right here, which is 100. So I have 40 over 100, which is about 0.4, which is about 40% of the people. Okay, here's the same table again. I added 3 more questions. So let's try the first one again together. So if I'm finding the probability of a 30 to 45-year-old age group, given, there's that slash, they are for the bill. So again, I'm going to follow the formula. So I'm going to find the probability of being 30 to 45 and for the bill, all divided by the bottom of the fraction for this probability is what comes at the end here, probability for the bill. All right, so let's take a look at our table. How many are 30 to 45 years old and they are for the bill? That looks like it's right here, 200 people. All divided by how many total were for the bill? Looking at this column, that's 780 people. If I was to go ahead and put that in the calculator, it would be about 0.26, about 26%. All right, now you go ahead and try number 2. Stop the video, come back and see if you got the right answer. All right, so for number 2 here, probability of 45 to 60 years old given against the bill. So again, I'm going to follow that conditional probability formula. I want to find the probability of being 45 to 60 and against the bill, divided by probability of against. So how many are 45 to 60 and against the bill? Well, that's here. There's 20 people. Divided by how many total are against the bill? And that's the total in this column, over 120. And that reduces to, 1/6, which is about 17% if you put in the calculator. All right, try number 3. Okay, so for the last one here, we're looking for the probability of not 18 to 29 years old given for the bill. So on the top, I'm going to find the probability of not 18 to 29 years old and for the bill. So let's take a look. Not 18 to 29, so that's everybody else. And for the bill, that's these 3 numbers here. So if I add up 200, 120, and 150, I get a total of 470, divided by the total amount of people for is 780. If I go ahead and put that in the calculator, it becomes 0.6, which is 60% of the people. All right, here's the last question here. This one's a little different. They don't have numbers. They have it as a decimal, which is a percent here in each column and row. You're still going to be doing the basic same thing here. They're telling us how many are part of this whole company, 150 sales representatives. And he made a table based on sales results. So we're going to take a look at numbers 1 and 2. So I'd like you to try it yourself first, pause the video, come back and see if you have the right answers. Okay, so for the first one there, I'm finding the probability of attending the seminar given increase in sales. So I'm finding the probability of attending and increasing, which if I take a look would be attending and increase in sales is 0.48. So that's going to be on the top, divided by total increase in sales. So if I take a look at this row, that's 0.5. Go ahead and divide that That comes out to almost 96% of the people, of those representatives. Okay, last one here. Probability did not attend. Seminar given, did not see increase in sales. So I'm finding the probability of not attending and no increase. Not attending and no increase is right here, 0.18 divided by probability of no increase. So if I take a look at this row, that's 0.5. Go ahead and do that in the calculator and divide. I get about 0.36, which is 36%. Okay, so the agenda for the rest of the class here is you have your homework to do, which is due by Monday. You also have a Google form to submit to me that has a question on there, and for attendance-wise, that needs to be submitted. That's definitely for today. If you feel like you want more practice for the quiz on Monday, I have attached an extra practice of ELRs there, a PDF, which has an answer key. If you want to, take a look and work and practice on those, that's up to you. Again, email me with any kind of questions. Hope everyone is doing well.